All right, I kind of see the conversation dying down a little bit. So let's go over some of these real quick. Okay, so let's pretend that I'm a contestant on the show. What size interval would be best for me? Haley?
Is it larger?
Mm-hmm. Yeah, like a really big one. And why is that?
There's more.
All right, Brittany. Yeah. All right, Brittany, why don't you say yours?
Oh,
Lost train of thought.
Yeah, lost train of thought.
All right, Haley, you want to go?
because like the bigger the interval, the higher chance like the interest rate is. That range.
Yeah, right. If I had a really big interval, I'm going to be more confident that the population or the mean is going to be in that interval. The bigger the interval, the more confident I would be that I would win the game, right? So let me write this. A larger interval. And my reasoning for this is I'd be more confident that I would win, right? Okay, so I'm going to go back to this idea of confidence later on, but I will be more confident that I would win in a larger interval. In fact, if the interval was as large as the entire game board, I would be 100% confident that I would win, right? Okay. Let's move on. Let's just say, let's switch roles here. Instead of a contestant, I am the show producer. What interval would I want here? Smaller one, good. So a smaller interval. And I guess the opposite logic would work there, right? I would be less confident that I would win. Any other ideas? All right. Yeah, that's what I'm kind of thinking. We'll go back to this in part E, but I definitely think a smaller interval would be better as a TV show producer because you don't want people to win. You don't want to give out prizes all the time. Okay. Next question. Let's talk about what would happen to the rate of prize winning. Let's just say the red interval was really narrow, so it was really small. What would happen to the rate of prize winning? Claire?
It would decrease.
It would decrease, right? Because, well, we're not really sure that the mean is going to be in there anymore, especially if the red interval is really, really narrow. I don't think the population mean is going to end up in there. So this will definitely decrease. Okay, so the narrower the interval, the harder it is to win. Okay, and then I guess using that logic, if the red interval was wider, the rate of prize winning will increase, right? Because more things will go, more populate. There's a more chance that the population mean gets in there. Okay. So now with our findings, we know that, okay, if the interval is really small, then we're not going to win as much. And if the interval is really big, then we are going to win. Shouldn't all intervals just be really big then so that we win? And why not?
Less often. So instead of you're trying to like encapsulate one purpose of like how many people are more frequently to win versus how many people are more likely to lose, it doesn't like separate both.
Yeah, so you're saying there's some like sort of trade-off, right? You want it to be big enough so that people win the game. You want it to be small enough so that the show's interesting, right? I like watching when people lose, but I also want to see people win as well, right? So I'm going to say no. And the reason for this is because a large interval interval. So winning with a large interval isn't very meaningful, okay? I'm going to compare this to another situation. So what if I told you to estimate the average age of every student at SU, okay? Maybe I would say it's between 18 and 22, and that would be pretty meaningful. But I could also say the average age of everyone at SU is between, I don't know, 0 and 100, right? Now, I'm way more confident that the average age is between 0 and 100, but it doesn't mean as much if I say that, right? No one cares that the mean is between 0 and 100 because it's pretty obvious that it is, Okay, so the idea behind confidence intervals is we're trying to estimate the mean of something. We're creating this interval, and we have to figure out how large or small it should be, so that it encapsulates the population mean and it's meaningful. Okay, so it's not something stupid like saying the average age is between 0 and 100. Okay, all right. Let's move on. Now that we have that in our head, I think it'll be a lot easier to understand what confidence intervals are. Before we do that, let's go over some symbols for our quiz and for the rest of the section. Can someone tell me the symbol for population mean? M, but the Greek letter for it, mu, right? Mu, okay. What about population standard deviation? Sigma, good. Sample mean? X bar. Sample standard deviation? S, perfect. We are all good for the quiz. Yeah. Next up, we have an example. It's a very large example, and I hate word problems that are like a bunch of sentences long. So before I actually read this, I'm gonna go and, or while I'm reading it, I'm gonna go and figure out what all my variables are so I don't have to go back and read the question again. Okay, we got a simple random sample of 100 fourth graders. What symbol is 100 represented by? N, right? N is the sample size. So whatever size sample we have is N. Okay. This simple random sample is selected to take part in this new experimental approach to teach reading. Okay. So after they do this program, they give them a test and the sample mean is 67.30. So X bar is 67.30. And then it says on the basis of past results, we know that the population standard deviation, sigma, is 15. Okay. This question is asking us to find the population mean. Okay, so this is what the question is asking us to do. Now I'm going to tell you straight up that with the information we have, there's no way to find the population mean. Okay, there's no way I can put this information in anything and find one number that is the population mean. What I can do is create an interval that the population mean could be in. Okay. Before I do that, let's talk about how we might estimate what the population mean is. Okay. If I gave you this information and I asked you to find a number that is close to the population mean, what number would you give me? Not 100, close though. Not 15. The other one, right? Isn't the population mean, shouldn't that be close to the sample mean, right? If I take a sample and find its mean, samples are supposed to represent the population. The sample mean should be somewhat near the population mean. It might not be exactly, but we would expect it to be somewhere near that, right? So I'm just gonna rewrite this again so I can label it. Okay, 67.30, or our sample mean, is close or like approximately, so it's close to what we want. Okay, so it's close to this, which is what we want. Okay. Okay, because this is close to what we want, it's an approximation or an estimate of what we want. We have a name for this, okay? Because it's one number or one point, I'm going to call this the point estimate. Okay, point for one number, estimate for estimating my answer. Okay, I'm going to use this number to create an interval where I think the mean might be in it. The way we're going to do that is by using this term called the margin of error. Has anyone ever heard the term margin of error? Anyone kind of want to give an example of how it might be used? Okay, I'll give you an example. I used to give some of my tests on like the computer, so through my classes, and students would calculate stuff and type in their answer. And sometimes they type in a decimal and they would round it wrong, so they would get the right answer, but my classes would mark it wrong for some reason because it wasn't exactly the number that I said the correct answer was. Okay, now there is an option on my classes to tell my classes what the correct answer is, but then give a margin of error so that it gives like a range of numbers around my correct answer that would still be marked correct, even though it isn't exactly the right answer, okay? Margin of error is used a lot in that case. Okay, so like grading, I think it's used in a lot of like psychology terms. It's also used a lot in biology when things aren't exactly one number, but around that number, okay? Okay, so let me tell you how to use margin of error for this example here, okay? I know that 67.3 is close to my mean, okay? Now, for no reason at all, I'm gonna choose this number 10, and I'm gonna say my margin of error is 10, okay? What this means is I can take an interval, and I know this is not gonna be drawn very well. I'm gonna take 67.30 and stick it in the middle of my interval. So that's gonna be kind of the center point of wherever my interval is, kind of like the middle of the red interval on the range game, okay? What I'm gonna do with this number, I'm going to add my margin of error. So 67.30 plus 10. Oh, wow. And that gives me a 77.30. I'm going to subtract 10, 67.30, oh gosh, did that wrong. 67.30 minus 10 to get 57.30, okay? And my interval, or that confidence interval that you saw going up and down on the range game, is between 57.30 and 77.30. Okay, so that's my interval of values. That's where the range game starts and ends. Okay, I'm gonna write this in interval notation by putting them in parentheses and putting a comma in between. So all that says is my interval starts at 57, ends at 77. Okay. Any questions on what I just did? All right, I have a question for you. What I'm gonna do is give you a few minutes to answer this question. Same question, if the margin of error was 2, I want you to figure out what the interval would be. Okay. All right, I think everyone's close to done at least. The number in the middle is always going to be my estimate. So my point estimate, or 67.3, is going to be in the center of my interval, okay? How do I get the lowest number? Subtract 2, right? I'm gonna take 67.30, subtract 2, and it gives me 65.30, okay? How do I find the highest number? Add 2, right? I'm gonna take 67.30, add 2, and that gives me 69.30. Okay, so my red interval that goes up and down is between these two numbers on the left and right. Okay, so 65.30, comma 69.30. Okay, I'm going to ask you a question. We went from a margin of error of 10 to a margin of error of 2. My margin of error is smaller when it's 2. What happened to the interval? Did it get wider or narrower? Narrower, right? When the margin of error is small, so let me write this out. A small margin of error, that means a small interval. Okay. All right, I almost fell off my chair. All right, let's go to the next page here. Yeah.
I just have a question for the math part. Should we show that on a quiz? So like the box would be added. So should we show that, or can we just write it?
I'd say if you can do it in your head, that's fine.
Okay.
Yeah. Yeah, that's a good question though. All right, so I know I just threw the numbers 10 and 2 at you for the margin of error. There's actually a way to find a margin of error that answers our question on the first page. Something that is large enough so that we encapsulate the population mean in it, and that's small enough so it actually means something. So we're not just winning the game all the time, okay? I'm gonna throw this word at you, and we'll come back to what this means. I'm gonna throw this word confidence at you, okay? In this question, let's just say that we want to be 95% confident, okay? Don't worry about what that means. We'll go back to what this means later, okay? And we want to figure out how large the margin of error should be, okay? we need two things to be able to do that. The first thing we need is this thing called the standard error. Okay, now I don't want you to confuse this with the standard deviation. Okay, so these two aren't necessarily equal. Okay, sometimes they are, sometimes they aren't. Okay, so standard error actually has a formula, and its formula is sigma over the square root of n. Does that look familiar? Yeah, we did that in the last section, right? This was actually the standard deviation of the means in our last section. Okay, this is something I do want you to know. So I want you to memorize that this is the formula for standard error. You already know this formula, so it's not much memorization. Okay, so let's go ahead and find the standard error in example 1. Remember in example 1, I had that n was 100. We didn't know mu, but we knew that sigma was 15 and x bar was 67.30, right? Okay. Using our formula, we know that standard error is sigma over the square root of n. Okay. Sigma is 15, n is 100. Now, I always recommend doing the square root first and writing it down. So the square root of 100 is 10, and the standard error is 1.5. Okay, so I just plugged everything into my formula. Okay, now you're probably wondering why I even said 95% confident, because we didn't use 95 in this whole calculation. The reason I said this was because we have another number that we need to calculate. And this number is called a critical value. Okay. So a critical value is something that is found in a very particular way that involves a lot of calculations that we're not going to do in this class. Okay. All I'm going to tell you is if you want to find the critical value for a question, you're going to figure out what the confidence level is that I give you. And then you're going to look in this chart and figure out what it is. So in this class, we are 95% confident for this question. What do you think the critical value is? 1.960. You're looking the right place. Right? We are 95% confident. Looking at my chart, it says 1.960. So that is my critical value. Some things about this chart, I do not expect you to memorize this chart. Okay, so please don't memorize this. Okay, I will give you this chart in any quiz or test that requires it. Okay, so no need to memorize the chart. Okay, so we found our critical value. We found the standard error. I'm going to tell you how to find the margin of error now. To find the margin of error, we take our critical value and we multiply it by the standard error. Okay, so can someone tell me what I would multiply to get the margin of error here? Perfect. Right, on this page, we found that the critical value was 1.960. We also found that the standard error was 1.5. Multiplying these together gives us 2.94, which is our margin of error. Okay. Remember, the margin of error is what we add and subtract to the sample mean or our point estimate to get our confidence interval. So let's just go and find our confidence interval. Okay. What am I adding and subtracting 2.94 to? What number am I doing that to? 67.3. Good. I don't know why I wrote 27. 67.3. Okay. We are always, and I'm going to write this out. We're always going to add and subtract the margin of error from the point estimate. And remember, the point estimate is X bar. Okay, so 67.3 goes in the middle. How do I find my lower number? Yeah, subtract 2.94, right? So 67.30 minus 2.94, and that gives me 64.36. To find the other one, I guess we have to add, right? 67.30 plus 2.94. That gives me 70.21. So the width of my interval is going to be between 64.36 and 70.21. Okay, this is my confidence interval. Any questions on what I just did? Nice. Next class, what we're going to do is we're going to explain how we interpret our answer. There's a very specific way that we say it. We'll also talk about how to piece everything together, which is, I think, kind of the hard part of doing this. But I think we do have a quiz, right?